And today we're going to talk about, it's called traversing two verticals, uh, because this was how it was, this is the title class when I was a student. And I think that it's a good term for it, but I think that's really more an exploration of the law of Demeter. And I've mentioned the law of Demeter to you in the past. And I want to revisit specifically because like the stuff we're going to talk about right now is something that is going to be expected to be delivered in your project. So like the stuff we're covering now is pretty much the basis of the big refactor that you're going to do for your project. At this point, you should have, at least on the way to having most of the functionality of the project done. And I just noticed there is no lesson plan for this class because this is a relatively newer class, but I do have notes and I'll be sharing that with you afterwards. So it is, a lot of thoughts right now. So the law of Demeter, it's a good guideline for writing good OP software. Some terms that you'll hear associated with are loose coupling. We're going to go into that a little bit more. I think that like, I don't like to define loose coupling because I actually don't know what the definition of loose coupling is, but I know it when I see it. And I think that after today, you'll start to kind of see what it means. I'm sure that I'm positive there is a formal definition of it. I just don't know off the top of my head. And sometimes, and I like this a lot, it is the principle of least knowledge. We're going to talk about like what that actually means, like a little bit in the future, like literally minutes in the future. And finally, I think the best way to sum it up is each thing should only talk to its friends and not its friends' friends. Cool. And I think that what we've kind of communicated this to you in the past, is that when we are doing code, like this idea of like chaining methods on methods on methods, it's kind of reach through objects. We kind of want to avoid doing that. Cool. That's all really, so let me save this. And what I want to do is that I'm going to use an example of this previous project that's very similar to football. It's an old project called Sales Engine. And it's very similar in structure to football in that what it did is it took a lot of sales information, from an application, and we wanted to run some statistics on it. Right. So we would have like a CSV listing all the customers, a CSV listing the merchants, CSV listing items, and so forth. Right. And so we are going to look, we're going to kind of talk in particular about what we call two verticals in this. I mainly want to talk today about in this sales engine project, the idea of just having merchants and items. We have a CSV of merchants. They have ID numbers. They have merchant names. I think perhaps a good example of this might be like your teams. They have a name, they have ID number. And we also have items, right? And in this item CSV, we have ID of an item, but we also have a merchant ID. The idea behind this is that a merchant may be selling multiple items, but an item is only sold by one merchant. Does that make sense? Right? Like the idea is that like, I think maybe a good idea, a good kind of like real life examples is like Etsy. When we go into an Etsy store, we see this person, a merchant selling all these different kinds of things, but each kind of thing in there is only sold by one merchant. Like a merchant, multiple merchants don't sell one thing. So the relationship here is that a merchant can have many items, but an item can only belong to one merchant. Right? And so we kind of have the structure built out when we kind of want to build this, is that at the top level, I'm going to try to draw using text. We have our sales engine object, which is kind of like the top level thing. It's much like what did some of you call your top level object for football? Statistics. Some people may look at statistics. Anyone volunteer about what you call your top level object? Anyone? Just anyone shout it out. Be brave before I pick someone.
Stat tracker.
Stat tracker, cool. Like you're using your top level object. And what we do is, oh, how do we make diagrams using text? Yes, there's the other key, right? And the idea is that the sales engine will make a item repository. I'm going to just call it repo for short, and a merchant repository. These are like one arrow's going to one goes the other. And this is how I kind of want to divide up the kind of work here, is that sales engine is going to be like the kind of main object that kicks everything off. Also, you all can see my screen, right? Just make sure. That would be very awkward if I've been talking for this long without it. And the sales engine is in charge of initiating, creating these objects, the item repository and the merchant repository. And what the item repository is responsible for is going to be creating the items, all the item objects we're going to have, and like kind of like anything to do with the collection of the items. Like can we find an item by its name? Can we find an item by its item number? And the items down here are a collection of the actual item objects. And over here for the merchant repo, I'm going to make another arrow. And down here, it's going to be the merchants, right? The individual merchant objects. And this is how we kind of want this kind of structure to appear, is that you have the sales engine, which kicks off this kind of collector object that will kind of load everything up and create these objects for us. And this is a hint to you, is that if you are not creating game objects, team objects, and you're just doing something else, no, we need to have these game objects. We have these. We are expecting everything to be objectified. That doesn't feel like a good word to use, but we want objects created for all these things. Cool questions so far. Excellent. So what I kind of want to kind of like draw attention to is that we've created a hierarchy with different layers, and each layer is responsible for a different thing. The sales engine is responsible for creating these repositories. The repositories are going to be responsible for the creation of these objects, and then we have the object, kind of the units down below. Code that I would probably find in the repos, what I would call like your finder methods. Let's say you have a team ID. I need to figure out, I need the team object back that has this ID, grab it, things of that nature. And like the individual items and the merchants would have their attributes. Right. So what we have here is that we have the situation. Maybe I should move this over a little bit to make it a little more clear. Better? Yeah, that feels better. Yeah. The problem here is that when we're down one leg of this pair of pants, and we got to get something from the other leg. For example, here, should not an item know about its merchant? I mean, what if we need to grab that thing's merchant, like real quickly? What do we have to do? What do we think? Catherine, what do you think? How'd you do it?
We've got to go all the way back up and then down the leg. So you have to go back to item repo,
yep.
And then.
Well, yeah. I mean, that's how we're supposed to do it. But like, I think that what happens is that like, well, why don't I just instantiate a copy of a merchant repo in my item, and then I'll just have access to it. Why do you think that's a bad idea? Adam?
If you make changes to your merchant repo, you've got to track that and make changes.
Yeah. Yeah, totally, right? The idea is that when we do that, we're essentially creating a copy of every single like merchant repo or other repo in every single thing of item. That's a lot. So how long does it take some of you to run your tests? Are we hitting the point where some it's kind of like pretty heavy? every single time. That means that every single time we are instantiating a merchant repo, we also have to instantiate however many merchants are under it, belong to it, whichever, like both make sense, right? And so in your, let's just use the football example. How many teams are there? I don't know. I'm literally asking.
Like
That's
60
10.
some.
60 something.
10.
I've got a lot of range of answers.
32.
There's 32 teams.
Okay. Are we sure? Are we in agreement on this? Because it feels like there was some. Okay. Well, let's just say 32, right? 32 teams doesn't seem that like that. That's a lot, right? Like 32 teams is fine. And let's say we reinitialize and reload the CSVs and create them 30 times. Not a big deal. But the term we want to use is that like this does not scale. Let's think about it. Like let's think about a system such as Amazon's that has, gosh, gajillions of items and gajillions of merchants, right? That does not feel good. Like having to, every single item has a copy of all this. Like, no, let's not do this. So the idea is that, like Catherine said, we kind of want to go up the pants leg. This is the worst analogy I've ever come up with. Go up one leg of the pants and down the other. This only works with two, like unless we had octopus pants, but I don't think that's a real thing. So what we're doing essentially is that we are re-replicating copies of things everywhere. And if we were to expand our application to where things could get modified, like what if like a merchant decides to change their name? How many places would we have to go to check to make sure that's been changed? At minimum, once for every single item. That doesn't feel good. And so we want to make sure that when we create information, it exists in one and only one place. Like the term we kind of use is single source of truth, right? That we have when we look for the merchant, there's only one place where this happens. It's not kind of going anywhere else, right? So, so essentially what we're doing here is that we want items to be like, okay, I want to create, like, I think that we also want to like do something like we want methods to kind of work the way we want them to. So if I had an item and I wanted to get its merchant, what I would want to do is that I would create a merchant method for an item that will return me the merchant object, right? Item.merchant, well, he'll give me the merchant object back. That's fantastic. And so the kind of what essentially happens is that we run item.merchant, and the item object, the item class is like, okay, cool, I want to know my merchant. And that's fine, but I don't know anything about merchants. What do I do? Well, I should ask my friend. And in this case, the object only has one friend, the item repo. So we are going to say, hey, item repo, I'm an item. My item ID is called 5. Can you find out who my merchant ID is 5. Can you find out what merchant that is? And then the item repository, I'm like, well, I don't know anything about merchants, but who's my friend? The item repository is 2 friends, all the items it's created in the sales engine. So the item repository is going to go up, it's like, hey, sales engine, I have got this merchant ID. I need a merchant. Can you help me out? And the sales engine is like, oh, you need to know something about a merchant? I know who knows things about merchant, the merchant repository. And so the sales engine will ask, hey, merchant repository, give me a merchant that has ID. Merchant repository, much like your game manager class or team manager class, like whatever you've called it, it's like, oh, I've got this collection of, this merchant is going to be, I've got this collection of merchants. Which one has an ID of 5? That one? Okay, cool. This is the object, and it sends it back up and down the down the chain. And this is what we mean when we say we are traversing 2 verticals. We're going up one vertical to the, like, essentially the junction point and going down another one. Questions at this point? Max?
Yeah. Are you going to show us what this looks like from inside, say, item repo?
Yeah.
That object?
Yes.
Awesome.
Just not there yet. Yep. Catherine?
Yeah. So when you're going through these, wouldn't we be chaining a bunch of methods? Like
No,
you'd
and I
go.
think
Okay.
we are, but we're not, which is the best answer I could possibly give you.
Okay.
When we start getting into code, I'll show you like why it's not.
Okay.
Cool. All right. So let's write some code. Let's start writing some code here. I'm gonna item. Cool. Did I miss anyone? Sales. Nope, that's all of them. Cool. So I have my sales engine. I'm not gonna write any of the require methods. Just assume that everything's required up. Class. Cool. And let's say def initialize. Nope, we'll do that. We'll do ir equals item repository new. And what I want to do is I'm just going to pass it like I'll just call it the item path. I'm just going to use it as a filter. So like that's going to be the path to the item file wherever that lives in your stuff. Cool. And MR is going to be merchant. And so now let's do the item repository first. What am I doing? Def initialize, and this is going to take the path. And what I might do here is I might have a method. I probably would do a thing called create items, a method called create items. Then down here, I would have a def create items path. Pass the path. And here I would do at items equal, like here's where I would just whatever code it would take to load from CSV and create. Let's just kind of like let's actually do it this way. Data. And so I would probably create a file IO object and give it a method that'll just load me whatever it is and give that back. And that'll be CSV data. And then I would do at items equals CSV data dot map do item. Nope. Not new row. And let me make an item. Any questions about what I've written so far? Essentially, the sales engine will initialize these repositories. The repository, upon creation, will take the path that's passed to it from the sales engine. It will go and kick off this process of loading in the stuff from CSV and then creating new item objects. Ben?
In our item class, is just like this, like the attributes of what the item is. There's no behaviors in that item class. Is that correct?
So far.
Okay.
Any questions? I'll pause here. Surely.
Are you still using the moon lander?
Mm-hmm.
Good job. You got it
Thank
so
you.
fast.
It's been about a month and a half now. It's getting there. We're getting there. Cool. And so I'm gonna, yeah. And so we expect to have items in this, methods in this repository, like maybe like find item by ID. It's gonna be we're gonna pass through ID, and it will be at items dot find to item where item dot ID equals ID. Right? Like you probably have methods very similar to this in your current code. And this is where they would live, right? Because you're searching through the entire thing. Right. And so I'm going to do the same for merchant repository. Let's just pretend we did very similar to the merchant repository. And so we talked about this idea is like where we want, so we want to find out a merchant, right? We want to find an items merchant. We want that to return the merchant object back, right? And so we're here in item and we create this merchant method. So like how? And this is the hard part, isn't it? We've diagrammed out here that we want our item to talk to item repo. But if we're in item, we can't talk to our item repository. Can't we? Because like when we can go down this tree is kind of like a staircase, but we can't go back up, right? So like when we talk about, for an example, your mid-mod diagnostic, you had courses and students were in a course, right? And if you were at the course level, you had all the students, but if you're a student, could you tell what course it was in? Could you somehow figure that out? You couldn't because you didn't have access to it. It was not in scope. So we need to create this link between item repository and item. And how we can do that is with self. What self is that it is kind of a pointer towards the object that we are currently in when we actually run it. So what I would do is that when I'm creating an item, I would pass in self here. And self is essentially this instance of the item repository. And so I go over here. It's got, we send in, when we pass a new thing to new, we got to create and initialize. Oops. We have parent. I call it parent because that's the logical kind of progression. Like, hey, like the item is kind of like this child object of the thing. So, and I'm going to save that. Parent equals parent. So now what I would do is that I would just ask my item repository, parent, hey parent. Oops. We also need a merchant ID. So here in parent, I'm like, hey parent, And because I haven't done this yet, I'm like, well, like, you know, if I have the merchant and I want the merchant ID, I would say, hey, parent, hey, item repository, find merchant by ID, and I want to pass it my merchant ID. So what happens here is that, like, okay, well, if I run this now, let's say I had a test screen that's working, what would be the error? What do we think? Aiden?
Is it like outside of the scope of item?
No, because we passed down parent, which is an instance of item repository. What's going to happen is that it's going to be like item repository does not have a find by merchant ID. So we got to create one over here. Find merchant by ID. If I think that's what I said. I don't think I said that, but that's what I meant. Find merchant by ID, and it's going to take an ID. And so now our item repository wants to ask sales engine, hey, I've got this merchant ID. Can you give me the merchant object, please? But what's the problem? Joe, what do you think? Joe J. Yeah.
I'm not sure.
Fine. Mike, what do you think?
I don't think there's access to it.
Yeah,
Not really
it doesn't
sure.
have access. Much like item did not have access to its parent until we made some changes, item repository will not have access to its parent unless we change things. So we do the same thing. Sales engine, when we're instantiating the item repository, will now pass itself. And what self refers to here is that it is going to refer to that its current instance, right? So in this instance of sales engine, the reference to it is going to get passed down to the item repository. And where are we? Here, path, parent. And I'm going to do parent equals parent. I'm not going to make an adder reader because we're never going to use this anywhere other than internally, so we don't touch that at all. And so over here we have this method. We now have to ask, hey, sales engine, parent, find merchant by ID, and we're going to pass it the ID that comes in. So now, where we got to go to make changes? Robert, give me your thoughts. Ooh, I scrolled way down too much. Yeah, where are we going now?
Make changes for what? For the
What's my next step? I add this parent find by merchant ID, find merchant by ID.
so that you need to find merchant ID and parent.
Yep. And what's my parent here?
Parent is
What is the parent of the repository?
Parent of the repository is the sales engine.
Yep, exactly. So over here in sales engine, we now got to make def find merchant by ID. It's going to take an ID. Right? No, go move over. There we go. And so now we're at the top level and find merchant ID. So sales engine is like, okay, so how do I get the merchants? Well, I have the merchant repository. I can just ask the merchant repository. So I do, these should have, yep. This should be, hey, merchant repository. And I'm going to presume that you've already made a method like this, find by ID. And so the merchant repository is like, hey, you've already made a method for this. It'll grab the merchant object, pass it back to sales engine. Sales engine is going to pass it back to item repository. Item repository passes it back down to item. And now we have this item method where this merchant thing works. So yes, we're not chaining in the fact that we're just writing things like over. What we're doing is we're asking a friend. We do not ask multiple friends over. We only ask our nearest adjacent friends. So like this is something I want to see. I do not want to see this. Merchant ID, like that. We reach 1 over, never more than over. Sydney?
So sorry, I'm having some internet issues, but you might have already said this. Why did we give item repository and sales engine self?
Yep. So go ahead. Go ahead.
Yeah, go ahead.
No,
No, I'm sorry. Go ahead.
Okay.
No. Sorry.
You say bye. You say bye. You hang up. I'm kidding. The idea here is that we want item on its own does not know how to talk to the item repo, and the item repo does not know how to talk to sales engine. So we have to pass a kind of a reference to itself so it knows about where it came from. If we did not pass down the parent and store it here, there would be no way for item to reach upward and so on up the chain. Cool. Adam?
Yeah, similar question. When you wrote parent the first time, you said it makes logical sense to use this word. Can we use like X? Can you type in whatever you want? Or do you
you call it whatever you want. It's just we're just storing things in the instance variable.
Okay, so whatever you put as your second initialize is going to connect to the self. I'm struggling to understand how we know that's not just some variable.
Yeah, I mean, so self is a special word that refers to this instance of whatever it's in. We don't really care what self is doing under the hood. Like, for all intents and purposes, self is just a thing we're passing through. It works just like any other parameter / argument, whatever.
Okay, got it. So it doesn't matter what you call it. It's just looking for find merchant by ID, and because we self, it'll look until it finds it, which is in the item repository.
Not quite. The thing is that self is of reference to this item repository. What we're doing is that we are giving item access, like kind of like an address to where you find it. So this parent, if I were to put a binding.pry in here, and I did puts parent.class, it would say item repository. We are like passing a reference to it. If I did just puts parent, it would do the notation with the angle brackets. We are sending like essentially self as a reference to the original object. So we're letting item know how to reach it, and we can actually give it the opportunity to call on it.
Okay, thanks.
Jesus, and then we'll take a quick break.
I have a question. Just the method find merchant by ID, you had to write it in a couple classes. Is that something that you could do in like a module instead of having it all over, like redoing it every time?
You could, but I don't think it'll work the way you want it to.
Okay, so just keep writing the method every class to have access to the parent. That's okay practice. Okay, cool.
Yeah, because it's not really, you're not saving anything by doing that, right? What you're doing is that you're using these to communicate. There's no real like logical lifting or math lifting here. All right, let's take a break. See you back at 2:42. All right. So how many of y'all's test suites are like super taking a long time to run? Am I unmuted? Yeah, I'm unmuted. Wow, right? How long? Mike, I see your hand. How long is yours taking to run? That's either 8 minutes or 10 minutes. You still got 10 fingers up, regardless of how you do it. So we're approaching like 10 minutes. And this is like one of the strategies. Like this actually kind of helps you out a bunch with your testing. Because we're writing small methods and they talk to each other like this, when we are essentially testing an item, we no longer have to load up everything. Like what if your test suite is taking an absurdly long amount of time, what's probably happening is that for every test, you are loading up your CSVs, you're loading up the entire chain of everything that's happening. But what have we kind of talked about that has helped us speed up some testing, especially when multiple classes are involved? Starts with
The spec harness.
not the spec harness. The spec
Or
harness is
right-
what you're mocks and stubs. When you are testing upward motion, you can use mocks and stubs to fake out your repository methods, and therefore now you don't have to load up a full or even partial data set. However, when you are testing your item repository, you're still searching down, so that stuff you kind of have to test. But if you've been writing tests and doing this in a way where you're kind of like build yourself this mesh of objects interacting with each other, moving to this kind of format will drastically increase the performance of your test suite, and it will allow you to kind of speed that along. Yes. Cool. Let me check my notes. There's nothing else I wanted to cover. I want to open up to questions about what we've talked about here today. It is expected for the second half of your project that you move to this kind of structure. This will be required for you to do. Adam?
If we want to see more examples of mocks and stubs, how that used, would you say just watch the lesson again and go through that, or could you do an example given this? I know you don't have a test, but
yeah. Let me see if I can find one. I think I have an example, but I'm gonna find it first. GitHub.com. That's the name of the website. I have an example, but it doesn't use Mocha. It's this here. Make this a little bigger. It uses the mini test mock, and essentially what I'm doing is that I'm like, I'm saying, hey, this method is going to touch the sales engine. Does it do that? Does it do the thing? And it's just verifying it hits up. Like the idea is that I'm not expecting when you test this, right? Like this idea, like you're not going to be testing that this merchant method is going to retrieve you the appropriate merchant ID. You're going to test that it touches the object above it. And so you're going to, you use mocks to see like, hey, did it hit the repository? Did that method get called? Cool. Because on the other side, like you're going to test that the sales engine can talk to the merchant repository, and the merchant repository, given an ID, can grab the appropriate thing. So you'll like this will cut like a third of your testing down. That feels about right.
Got it. Thank you.
Mm-hmm. And the thing is, like this, the idea here is that if you want to write a well kind of planned out application, we want to see most of the logic pushed downwards. Your time figuring out some like the heavy math and logic kind of stuff, you'll have an easier time of it if you make these methods in your what we call model levels. The more methods you have to help you out with your game team, in your game team object, your game object, your team object, the more stuff you have in there, the easier it will be for you to kind of string the logic pieces together. Karen?
So the stubs that we create are the methods that touch our parent class and kind of just like create these chain of commands, right? So I'm confused on how to use stubs in this instance, because I know that we're creating an object of every single line basically in each of our CSV files. So like we actually want to be able to access all of those objects information. How are we going to use mocks?
So the idea here is that like what I would do is that let's say I was testing the item object. I would create a mock to take place of the item repository, and I would create an item object with a row of data and that mock in place of the parent. and then I would make sure that the method was getting hit there.
Okay, can you say that again differently? If not, that's like totally fine.
Because the thing is, you know, again, I'm just like, the problem is that like I don't remember what I just said. So I'm going to say it again, and hopefully it'll be a little different.
Okay.
When I'm testing, for example, if I'm testing this item object here that you see on my screen, what I would do is that I would create a mock/stub object in place of the item repository, and I would do like, so I'm just gonna throw it at the end of this file. I would do like mock equals, you know, like whatever I'm gonna mock, whatever, like whatever code that is to mock the item repository, and then I would have a row of data that would be, you know, ID 4, name, Baby Yoda, only days till the new season, merchant ID 8, and I would have item equals item dot new row mock, like that. And now your item parent is the mock object. Cool. Mike?
So before you mentioned that all the logic methods will be at like the model level?
I'm not saying all. I'm just saying it would probably help you to figure out what you can put in there to help you, because the idea is that you'll probably have noticed that as you're like grabbing shit from like everywhere, you're doing a lot of the same things over and over again, and like kind of taking chunks out of that and pushing it down to the model level. You'll probably find there's a lot that you can reuse.
So most of the heavy lifting of the logic, we could go down to the model level.
Ideally. I'm not saying you have to put everything there, but I would like to see some stuff move there, because that's generally just a very good refactor. Because like I would say like mostly anything that you find, that it's going to get duplicated somewhere else. So like finding what duplication you can and pushing it down to the model level is a good pattern to get used to doing.
For like a very loose connection of ideas, could we compare Stat Tracker to be like the controller? Like indirectly, like very loosely, of like an MVC model? Is that what you're getting at, or am I just...
No, because like your repositories are kind of like the controllers.
Oh, okay.
Yeah. Max?
Yeah, so let's say you had a whole bunch of items and they all had weight as one of their attributes, and you were trying to get like all the items that weighed more than 10. That method would be in your item repository, but it would call a method that's in your item, or it would just call an attribute from your item.
My first pass, right? Let's call them heavy items, right? If I were to do this, my first pass would be I'll make a def find heavy items. It'll be items.find all do item dot weight greater than 9. Right? Just that'll be my first pass. My second pass, let me get rid of this here. My second pass would be this. This would be that.
Okay, that answers my question. Awesome. Thank you.
Yeah, and also this is presuming there is a weight attribute, there's an add reader, et cetera, et cetera. Gus?
Yeah, can you just clarify when you say model level, which level is that?
This level.
Okay. What is, just for to help with visualizing what's going on, like what does model specifically refer to?
Model, I use the term model because it is like essentially you have classes that model a thing.
Okay. Okay.
Right. Whereas a repository doesn't really model anything. It's a collection of methods that deal with multiple models.
Got it. Okay. Thank you.
Yep. Max?
Yeah. So can I ask a question that combines some of the stuff from this morning with this one?
Sure.
Okay. So I understand that we can use class methods to instantiate a class or copies of a class, instances of a class. And I kind of understand that when it fits within just the 2 levels, but as soon as now that we have the 3 levels, what does that look like from the sales engine?
The thing is that because we are different, we're like everything's kind of abstracted from each other. So what you do at one level doesn't really have that much impact on another.
Okay.
Because like when you do a class method that instantiates itself, all it does is create another method and returning that thing. What happens inside doesn't really matter.
Okay. I guess, so my question is, for instantiating, say, individual items, if you did that from an item repo class method.
Don't.
Okay.
Don't.
Gotcha. So you would actually do that when you instantiate the item repo as opposed to.
Yeah. So like I have it set up here. The pretty much this. So what's happening is that when we initialize a item repository, it's going to go ahead and kick that chain off by itself. You could, if you wanted to, make a you do def load, and we could do. Right, and then we can take this out of here, but we'd have to store path like that.
Okay, so just to try and put that into one piece, what you're saying is don't use class methods unless you're at the highest class of your.
No, what I'm saying is that so the reason why we made you do it with a class method in the sales engine is just so you could do it once and see how that works and kind of get that interaction down. If I was writing this myself, I would never do it that way.
Okay.
It was just kind of an arbitrary requirement to force you to kind of figure out how that works because it's important to see how that works. Cool. Karen?
Okay, so using class methods is not going to cut down on our testing time, correct?
No.
Okay.
It's just a different way to do things
right.
that we want you to know how, because it's important if you know how.
Okay, cool. And so with the law of Demeter, basically with that in mind, in terms of using mocks and stubs, we're going to be using mocks and stubs at our repo level. Would you say, is that
no, you're going to be using mocks and stubs whenever you need to talk, in general, when you need to talk upwards.
So our model classes are at our model level, we're going to be using mocks and stubs because they just
talk to the repos.
They just want to talk to their friends. And they can reach that because, okay, all right, got it. So in terms of setting up the organization of a project, we want our stat tracker to be at the very top, right?
Yep.
And then we want a collection of methods, and then we want our model level, our model level classes. Okay, cool, thanks.
Yeah, essentially your stat tracker is going to be this kind of this big traffic cop that goes and gets information. James?
Yeah, I'm not really sure how to ask this question, but here you have your parent. That's just a copy of the self, the level above. When would you want to inherit versus just creating a copy of the parent? And could you do both?
Well, inheritance is used as a different kind of tool. Inheritance is a way to drive your code and to instill some kind of hierarchy to your code. What we're doing here is just we're passing a reference so we can access it.
Okay.
Like the idea is that the sales engine here or your stat tracker there is essentially still a very separate thing. It's responsible for different things. We are not gonna like this doesn't fall under that generalization specialization model like dog and beagle and so forth. Like they're very specific, very different things. So we are just passing a reference. We're not we're not sharing behavior. We're not differentiating in any way. Cool. It is 2:59. You're all set. Enjoy the rest of your afternoon. Myself and Kat will be offline for the next hour as we have a fun meeting to go to. Don't tell Sal I said fun in that kind of tone of voice. It's very fun. Meetings are the best. Goodbye, everyone.
Awesome.
Shit,
Thanks.
this is recording on YouTube.
Yeah, you're recording.
Thanks, Mike.
Thanks, Mike.